Okay. Hello, everybody. Welcome to the session, The Swift's Word. Cut off the head of the Objective-C in Medusa. Some words about me. I'm coming from Germany. I have a PhD in molecular biophysics and immunology. I'm married, one dog, one house, one wife, and as you can see, I really like science fiction. So, Objective-C. So, who of you is using Objective-C? Okay. Who actually like it? Nobody? Okay, then you're right here. So let's talk about how we can cut off the head of the Objective-C Medusa. If you look at this is a typical code snippet from Objective-C, and it looks really crazy and a little bit like a very old-fashioned programming language. It reminds me a little bit of my time in university when I was programming in Fortran or so. So there must be a better way. And if you look at this snippet from Swift, it looks way better. It's readable, it's easy to code, you can easily see what the code is actually doing, and that's the right place for the Objective-C box, as you know. Okay, so what is Swift? Swift was introduced by Apple at the Worldwide Developer Conference 2 years ago. It is now available in its third generation, so it's actually with XCode 8. You can use Swift 3, which has some changes to the overall language. The language is now becoming more mature. It's easy to hand. And it was thought as an innovative way for programming. And it was meant as an Objective-C without the C, so no pointers anymore. Pointers, rest in peace, we don't need them anymore. We have functions as first-class objects, we have closures, we have chaining, we have a very easy and expressive syntax, and what is really important, the apps run lightning fast. This is not like in programming in Java where you have the virtual machine and you have all these performance issues. The code is actually running really fast. Initially, it was meant for programming on iPad and iPhones, but you can also use it on OS X. And if you like running it on a server, there, for example, you can run it on Heroku. There's also an open source variant of Swift available. So Apple made it available to the open source community so that everybody can use Swift to write awesome code. So one of the main features of Swift was the introduction of modern language elements. So one of them is closures. They are similar to Objective-C blocks, but they are first-class objects. And therefore, you can nest them, you can pass them around, and all these things which are used in closures like in JavaScript. So it's a very handy feature, and you will use it quite often when you start programming in Swift. Functions are just a special case of that. So the syntax for creating a closure is very easy, so you don't have to learn about how to create it. But it's a little bit complex to really use closures in the beginning. But at some time you'll get used to it. And a very, very cool stuff is completion handlers. So if you program for iPhone, for iPad, you have to do a lot of asynchronous stuff because you can't block the main UI thread, and you have to be really careful about it. And with completion handler, you can do complex stuff and just wait when it's finished, and then you can execute the code upon it. And this makes the code much more easier to use. It is more maintainable. And you will see it in our example when we create an IoT app, how handy the feature actually is. So, and I guess nobody wants that back here. So if you want to create a completion handler in Objective-C, you always end up in such language constructs. And after a while, nobody really understands what they was doing there. Okay, so I think we have enough theory now you use to program in Swift. But Apple gave us a very great gift, and they call it the playground. And it's not something just to play around, but it's very useful for enterprise programming because you can easily write your code, you can test it, you can test complex algorithm, and you don't have these typical round trips where you have to write your code in XCode, deploy it on your phone or to your simulator, start the simulator, have to wait for the results, fix the bug, and again. So you can easily do that. So I will show you, for example, the OAuth authentication in Salesforce, how easy it is to do and to easily test it. And with iOS 10, you can also run playgrounds on your iPad. And that is a really cool feature, because now you can start to easily test, for example, gestures and all these things which are normally hard to test. So and you can just start it, and then you have your playgrounds here available on your iPad, and you can do all the stuff. And it's very easy to do that, and you can learn all about UI elements. But I will show you that now on XCode. So I have to switch over. Wait a second for that. Okay, now we're in XCode, and what you see here, the Swift Sword, you can easily test your code. You can just write your code, and you see directly the results. You can create some views on it and see what is happening here. And here you see all the things, the variables, how they express. You can test nearly everything in playgrounds with the new versions. You can dig with all these language elements. You can create variables. You can work with dictionaries. You can make a complex algorithm on it. You have this handy feature about optionals, so there's no nil testing anymore because you can just use optionals. And with the if-let structure, you can easily test if there's something in your variable or if it's nil. So it's very easy. You can go over the switch statements and all the typical language elements. I will hurry up. So I have some nice features here. Update. So for example, you have some graphical expressions if you're running for loops. Just a little bit to visualize what you're doing in your program code. And you can also create closures. You can create objects and classes. You can access properties and everything, nearly everything what Swift make available, you can do it in your playground. And that makes it very easy. And if you have tested your code, you can easily copy-paste it into your actual XCode project. So it's a very handy feature. But I think it's not only testing about language elements, you can also do some UI creation on it. And if I have to start the assistant editor, and hopefully XCode will not crash. So now you can easily create a view in Playground. It can also run on the same code, is also running on the iPad. I can create buttons here, for example. I can make a slider. Currently I have only a view, but you can also implement a controller, so you can react of what is happening on the playground. And if you like, you can also do some animations. And animations is normally a very painful thing to create them because you have to do a lot of testing. But it's very easy with the playground because you will save a lot of time. And it's just some lines of code. You can test it until you have the correct duration, for example. I can easily change that here. Oops, sorry. So I have just to wait. And now you see it can directly testing my animation until I have the feature which I would like to have. And as I promised for you, we can also do some testing with the OAuth authentication. So hopefully it will display here. So forget the credentials, I will change them after the session, so you don't have to. But here I can directly test the OAuth authentication, which is normally a very hard thing to code it. And I've easily here present you two ways. So the one is a web server flow, and the second one is a username password flow. So if I just put in here, you see that is what I have normally on my iPhone. So I can directly test it here. So hopefully it works. So now I'm just logging into my developer environment, and I will be redirected to the redirect page. And what you can't really see here is that I have now the access code, and I can exchange that to the right tokens to easily do my OAuth stuff. And with this token, I can then work and test the REST API or the SOAP API. And I can do the same with the username password flow, which is also very simple. So what I'm actually doing here is that I simply make an HTTP request with a post, and after that I will get my data back. And if you look here at the debug, here I have the return, and I have the most important thing, I have the access token. And with this access token, I can easily do all the stuff and work with Salesforce. Okay, so that's the stuff with the playground. Let's go back to my presentation, and let's do some more awesome stuff here. Hopefully it works, it's the right page. Okay, so now we have tested the Swift code. We know how to authenticate against Salesforce and how to make some requests against it. The question is how we bring it together when we would like to create a new app. So because we have, for example, the mobile SDK, it's a quite mature SDK, or you have written a lot of stuff in Objective-C which you want to reuse in your Swift project. It is very easy to integrate and even to mix Objective-C and Swift code in one of your projects. You just have to create a bridging header. And then you can easily use all your existing frameworks, Objective-C code in your new project. And therefore you have all the things which are tested, which are running. You can reuse them, and then you can create a new project starting in Swift. So you don't have to throw away your old code. So this is one possibility. And the second one is we want to use a pure Swift approach. So a colleague of mine, Michael Epstein, has created a very simple framework for it. It's called Swiftly Salesforce. And with that, you can completely write your code in the Swift way. And you can use all the great features which are offered by Salesforce and by Swift. So for example, with the bridging stuff, you can see I have first created a request, and if I have the response, then I can do chaining with the then elements and can and make complex chains of requests. So I can send a request to Salesforce, get the answer. Based on the answers, I will send the second request, and it's very straightforward code, and it's easily maintainable, and everybody who looks at the code can understand it. Okay, so I promise you that we will create an IoT application. Did you know that your smartphone is actually an IoT super device? So if you look at all this stuff which I have at my home, my Arduino boards, all these sensors, and at the top left, the big one is an proximity sensors. And if you look at your smartphone, you have all these sensors in your smartphone, and you can use them. And the second main advantage of a smartphone is it solves the problem how to get the data from the sensor back to your back-end system, because you have a wireless LAN in it, you have GSM, and all the ways to transfer the data. So that makes a smartphone really as an IoT super device. And you can also connect via Bluetooth other sensors to it. So what I'm actually doing in my home experiments is I have some sensors on my Arduino board, and I send the data via Bluetooth to my smartphone, and from my smartphone actually to the backend. So that's what I'm doing. And it's very easy to test it, and I can use it. So let's imagine we have a small company. A small company, it's called Gaby's X on Demand, or maybe the Force with you, and they have very, very demanding customers. So what they're actually doing is quite easy. So they will pick up X at the X station. Then they will have a transporter, which is actually my wife. So, and you know, my wife and motorcycle, and you can see what usually happens. So we have some broken eggs because she's driving like hell. So, no. Okay, so the company said, oh, we have a very demanding customer, that's not good. We have some requirements. We want to survey our drivers. We want to know if something happens here. So if they create an accident, we want to know it as soon as possible, because of this guy, he will make something with us which is not so easy. So we want to equip each driver with a smartphone. He has to log into Salesforce. And we want to ensure that the delivery works. So we want to track the position if something happened. So we want to read out the GPS sensor. And we want also create records in Salesforce. And in case of an accident, we want to simply create a case. So I created this one. We want to react on the gyro sensors or on the accelerometers. So that's very easy to do that. And if we have a certain threshold, we simply trigger an event and will create a case in Salesforce. So this is a very straightforward thing here. So in the normal world, everybody would say, oh, this is so expensive, it will cost a lot of money, we need months to build, we have to build up prototypes, we need a complex infrastructure, we need servers, we need all this stuff. But with the power of cloud, with the Sales Cloud, the Service Cloud, and then smartphone, we have everything available. So we can just go straight ahead and simply create an IoT application, we can react on it, and if something happens, then we can very easily go and create a case in Salesforce. And I will show you now how to do that. So we will go back to XCode. Okay, so the first thing, wait a second. So in the storyboard of XCode, I've created a very simple UI element. So just drag and drop. I have a button here. The green one is just to start listening for the accelerators. And if I have triggered an event, and it will go back to the normal state so that I not trigger one after the another. So I just will create one trigger event. I have a simple label where I will write out the accelerator data, and for testing purposes, I have a logout button. So that's really straightforward. It was easily created. That's the complete UI element. You can do more complex one if you like. So, and now let's go into the controller, which is actually magic, what is happening here. So I will use the MotionKit. MotionKit is also a very easy available framework for Swift. And it helps me to read out all the sensor data. So I don't have to write much code. I just use a MotionKit, and then I get all the data from the sensors in a very easy way. Okay, so in my viewDidLoad function, I will just set here the MotionKit get accelerator data. And this is actually also the magic which I'm doing here. So I will ask every tenth of a second for the accelerator data, and then I get back the results here in the in statements. So I get these 3 accelerators for the 3 axes. I have it now, and it works asynchronously. It doesn't block any of my UI thread. I don't even have to think about that. So this is all I have to do here. And it will automatically execute the code every tenth of a second. And then I simply assign it to my values, and I will check for an accident. So that's what I'm just doing. I have set some thresholds, so if I reach this threshold, I will do what here is an accident happens. So that's the complete code for the sensor dating. Without thinking, it's very easy to write, and you can easily understand what I'm doing here. So if the accident happened, I simply will create a case in Salesforce. So now let's come to the Salesforce integration. First one, I have written a simple method to do the login, the OAuth stuff. And what I'm doing here is I'm using the Swiftly Salesforce SDK. It is based on the Promise Kit framework, so I can work with promises, and I can easily check if something was gone in the right way or if I have an error. So I can ease my error handling also. I don't have to do this all with this throw and catch blocks and so on. So I have straightforward code which is more functional oriented, and I can concentrate what I'm doing. So I have a firstly statement. First, I try to get the identity. I get the typical login screen on my iPhone. I put into my name, and if I have the correct one, then I can read out the user info. I do that just here for debugging purposes or just to show it. And with the second, then I can simply do some stuff on it. And I can also easily catch errors. So if something goes wrong, for example, I put in the wrong username or the wrong password, then I will end up in a catch block, and I can act upon it. So that's all I have to do here. And that's so. And now finally, let's create a case. We have all these fields, so I've created a custom object here for the demonstration. I will create here this array with different names, and I have always the code that I write some information in it. I will write the accelerator data, and I will write the GPS data into it. And the actual code to create the record is this one. This is a statement where I just executed to create a record. So I will do the type, I give the fields, I can act upon the results. I have here always an always statement, which is always executed, whatever happens. So I can use that, for example, to update the UI. And I can also catch errors, which in this case is just an oops, where something went wrong. So that's all I have to do here. And for testing purposing, I have also a view case. But basically, it's the same statement. It's just Salesforce API, read record, and that's all I have to code. And then I'm completely integrated into Salesforce and get all the data out of it. So that's all what we have done here. And now let's hopefully start to demonstrate it. So I've created this app in XCode 8 in Swift 3. So I have ported everything to the new version. And now I can simply start here the application. And if I just, so now I'm start listening to the accelerators, and if I check it, you will see it will be green again. And now we check in Salesforce what had happened here. So and if everything goes fine, you see I have here a list of cases. I've tested a lot of it. So I will just refresh it. And normally we would see here a new one. And that's the case. So we have the geo data, we have the accelerator data. I have simply by declarative programming made the map into it. I think this is the most common use case for formulas. And that's all. So now I have completed a complete IoT application. I can easily track what's happening. I have fulfilled all the requirements from the business. And it was very straight ahead, and I just need a couple of minutes to do that, and I need less than 25 minutes to create a complex IoT application. And now you can enhance the use case and can do a lot of other stuff with it because you have a lot of data available. You can easily write it into Salesforce. You have a straightforward coding experience, and it makes it much easier to create native applications which are directly running on your iPhone. So you don't have to bother with hybrid stuff. It is sometimes a little bit more complex. It has some advantages, but if you really want to do native programming and want to have access to all the sensors available in your iPhone, then it's a very easy and handy way to go. So now let's go back to my presentation here, and we are nearly finished with it. So basically, if you're creating a real IoT architecture, it is a little bit more complex because you have a lot of data. You have to work with the data, with the raw data. You have raw data to transform into information, and then you have to transform this information into knowledge, into action. So it's more a complex chain. I just used some data here, and my information is just if I have a threshold, then create an event. But if you have running it with thousands of guys, then it's not the right way to do it in this way. So you have to do like Thunder or Heroku to process your data. Otherwise, you will kill your Salesforce system because you will sending too much data to it. You will create too much cases and so on. But it is a very handy way to use your smartphone to it because it solves the major problem of all these sensor-based systems. How do I get the data from the sensor back to my backend? And with this smartphone, you have all things built in, like GSM, wireless LAN, and so on. Some words about Swift. Swift is extremely powerful. I really like to code it with this, and all my new projects are starting in Swift. So if I start to write in an iPhone application, I always use Swift now. It has a lot of language features which make it really easy to develop your code. The XCode playground is a fantastic feature, and it saved me a lot of time because I can easily test things. So I'm currently working with the gestures, and it is really cool to do that on the iPad. I did it in my flight to San Francisco. I had a little bit of time there, so I played around with it, and it's extremely good to use it. With Swiftly Salesforce, you have the beginning of a new framework for Swift. Michael Epstein is enhancing it over the next weeks or months. And if you use the sensors of your smart device, you can easily create awesome IoT applications. So, and that's it. 25 minutes are over. Any questions? No questions? That usually happens after it. Okay, then thank you. We have a question. Yes, it can handle it. It's all in the framework. So complete authentication stuff is coded into the framework. So you can just use some lines of code, and everything else will be handled by the framework. You don't have to worry about it. Yes, server-side Swift is available. You can look, there's a Heroku build engine is available. And Swift is completely open source, so you can download it. You just go to swift.org and you will find all the information. Okay, then thank you very much. Thanks to all the guys who makes it possible here. Have a great Dreamforce. Enjoy the keynote tomorrow and have a nice evening. Thank you very much.